In real-time analytics, events are coming in constantly. But to make sense of them, we may need to group them into meaningful time chunks. In this video, I'll break down different types of time windows and when to use each one of them. Now, what are time windows? Let's say we have this source. This source is emitting the events. An event is nothing but a data packet that happened at a particular time, so it has a timestamp. So what it says is that at this particular timestamp, something has happened and we recorded that data. So the data packet with the timestamp is an event. For example, let's say we have a website and we are monitoring the number of clicks on the website. At 10 o'clock, let's say we have 5 clicks happened on the website, then this is an event. So now, when these events are getting continuously emitted by the source, to make sense out of that, we have to do some aggregation, some chunking based on time. Let's say I want to get the events which happened in the last 1 hour. So we collect all the events that happened in the 1 hour and get sense of what's happening in that time window. Now, if you are doing it for every hour, let's say 10 a.m. to 11 a.m., this is one time window. 11 a.m. to 12 p.m. this is another time window. So we are chunking the data every 1 hour. This type of fixed non-overlapping window is called tumbling window. So a tumbling window divides the incoming events into fixed and non-overlapping intervals based on arrival time. One use case is the count number of logins every 10 minutes. So 0 to 10 minutes, that's a window 1, 10 to 20 minutes, that's a window 2, and so on. Now, obviously, if we have some non-overlapping window, we definitely will have an overlapping window, right? So when we have a fixed plus overlapping time window, then that is called a hopping window. So if this is the time, and we break the time, this is the window, let's say W1. Now the next window will start overlapping this time window. Let's say this is 10 a.m. This is 10:30. This is 11. This is 11:30. This is 12, 12:30, and so on. So my first time window is from 10 to 11. My second window would be 10:30 to 11:30, and then my third window will be from 11 to 12, and so on. Now, what is the use case for this? The use case is if you want to do some moving averages or running average, these kind of use cases fall into this hopping window. So a hopping window is a fixed size overlapping window that advances by a hop size. A typical use case is an average sensor reading in a 10-second window where the hop is every 5 seconds. So 0 to 10, 5 to 15, 10 to 20. That's how the window and the hop moves. Now we have another type of window which is called a sliding window. So we have the time and we were dividing this, let's say 10, 10:30, 11, 11:30, 12, and 12:30. And we have some events coming in. Previously, what we were doing is we were dividing the time into specific windows, 10 to 10:30, 10:30 to 11, or 10:15 to 10:45, something like that, and then grouping the events in those time chunks. But in the case of sliding window, what happens is it is all event based. Is let's say I want to capture the last 10 minutes data. Now, this 10 minutes will start from the event. For example, this event is there. The moment this event comes, the last 10 minutes data will be captured. And then this event comes, the last 10 minutes starts from here. Similarly, this. So this is all an event based. That's why it's a sliding window. It's based on an event. So a sliding window is a window that follows an event, often based on a time range around it. One use case is show me the last 10 seconds of the data continuously. So that 10 seconds duration will be sliding based on the event. Anytime a new event comes, the last 10 seconds of data will be captured and then will be outputted. And then we have something called session window. So we have the time and we broke up into chunks and we are getting the events. So in a session window, what happens is whenever the session is active, The window will be open only for the active session. Whenever there is a inactivity, the window closes, new events coming in, the window opens, the window closes when the session is inactive, and then whenever the session is active, the window will be open. One example could be there is your website and a user logs in, those events will be captured, but the user is idle for 15 minutes, let's say. Now, if you give a timeout 15 minutes, the session will be closed, and whenever the user again becomes active, the session will be active and the events will be captured. This is called a session window, where the events are grouped based on activity sessions. The window closes after a gap of inactivity. It divides the events into variable and non overlapping intervals that are based on a gap of lack of activity. And finally, we have snapshot window. The name says it takes a snapshot at a particular point of time. So what it gives is it gives the state of data at a single point in time. Okay, so we have this time and we have these events. Many events are coming in like this, and at any point of time you're taking the state of data. Similarly, at this point you're taking a snapshot or the state and then moving on. So it's a point in time data which takes the snapshot of the data at specific points in time, like every hour or an event trigger. One example is check the latest inventory levels at any point of time. So we're taking the snapshot. Okay, so these are the different types of windows which we use in real-time analytics. Now, which one to choose? If you want fixed summaries, then go for tumbling window. Or if you want moving or rolling averages, then hopping window would be a better choice. For continuous tracking, sliding window. For active or inactive sessions, a session window. And to get the current state, a snapshot window. So these are the different types of windows and their applications in real-time analytics. That's all for this video. Thank you for watching.